Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. The module will cover the following topics: the introduction, the probability distributions, the binomial distribution, the Poisson distribution, the exponential probability distribution, and the normal distribution. Finally, we'll have the summary. Dear friends, after the completion of this module, you will be able to know the meaning and the properties of probability, understand the random variables and probability distributions, understand binomial distributions, learn the applications of probability. First of all, I would like to give you a brief introduction about the topic. Friends, till now you must be well versed with some of the techniques of data analysis like mean, median, mode, correlation, regression, etc. Now it is the time to understand the concept of probability. Probability is simply known as chance. Probability is a technique that is used very often by the researchers to make decisions about their research work. Probability is a tool that helps us in knowing the type of the data and the tests that need to be applied for further analysis. This module deals with the broader concepts of probability and distributions. Here, you will understand how to use probability in research. In the current unit, you will be able to learn different theories of probability and will also understand the importance of probability in statistical analysis. The concept of probability is quite difficult and time consuming. Thus, only the basic concepts will be discussed in this module. In the present module, you will also be presenting before the probability distribution. The probability distribution of a discrete random variable is a list. There are different types of distribution that will be covered under this module like binomial, Poisson, the exponential distribution and the normal distribution. First of all, let's understand what the probability is. Probability, which is usually represented by the symbol P, can be defined as the percentage of times in which a specific outcome would happen if an event is repeated a very large number of times. In other words, the probability of the ratio of the number of times the event occurs or can occur. General meaning of the word probability is the likelihood of happening or non-happening of an event. Where the happening of an event is certain, it is said to be equal to 1, and where there is absolute impossibility of happening of an event, the probability is said to be 0. However, in real life situations, the probability generally lies between 0 and 1. Therefore, the probability can never be negative. It will either be more than equal to 0 or equal to less than 1. This can symbolically be stated as follows. The probability can be expressed in terms of a fraction or a decimal for a percentage, but generally it is expressed in decimals. The probability can be explained under two different schools of thought. First, probability based on logic. The first school of thought presumes that the researcher is dealing with a finite set of possibilities that are drawn randomly. For instance, if the researcher has to draw from a pack of cards, there is a fixed number of all the possible hands. Such kind of problems are relatively easier to compute. Herein, the researcher is able to recognize all the possible outcomes and count the number of ways that a specific event may occur. Then, the probability of that very event is the number of times that it can occur, divided by the total number of possible outcomes. For example, if we have to compute the probability of drawing a king from the pack of 52 cards, it will be calculated as below. Like P will be equal to 4 by 52, that is 0.0769. Hence, there are 7.69% chances that such a king will be drawn out of the pack of 52 cards. Wait. The second school of thought is probability based on experience. Under the second school of thought, it assumes that if a procedure is repeated n number of times and out of these events, if a specific outcome, say A, occurs x number of times, then the probability can be computed as x upon n as n becomes large. For instance, if a fair coin is tossed 10 times, there is no certainty that the outcome will always be 5 heads and 5 tails. Instead, the proportion of heads or tails can range anything from 0 to 1. However, it can be stated here that as the total number of repetitions are increased, the probability will get closer to 0.5. Thus, if the same coin is tossed 100 times, the probability of having heads will be more closer to 0.5. Further, with another 1000 tosses, the probability of having probability near to 0.5 will be higher. The probability distributions now. The usefulness of probability theory comes in understanding probability distributions, which is also called as probability functions and probability densities or masses. Probability distributions list or describes the probability for all possible occurrences of a random variable. After having decided the random variable and probability are assigned to all of such with values of that variables, it is then called as a probability distribution. The following table illustrates the probability distribution for various demand levels for an FMCG product. Here the demand is given in lakhs units and the probability corresponding to it. Like when the demand was 50, the probability 0.1. Similarly, going ahead, if the demand is 200, the probability is 0.15 and the probability of having of demand 300 is 0.05. The total has always been 1. Many times the probability distribution table as presented here is also presented in form of a cumulative probability distribution. The probability distribution given in the above table can also be presented and cumulative probability distribution as in the next table. Here the sales again in units and the probability cumulative probability. Now the probability of having 50 units is 0.1 and the cumulative probability is again 0.1. Now the probability of having 100 units of demand is 0.3, but the cumulative probability distribution will be 0.4. It comes out like 0.1 plus 0.3 and so on. So the probability of having 200 units of demand will be 0.15, but the cumulative probability will be 0.85. This is 0.15 plus the previous value of 0.70, like 300 units, 0.05, and finally it comes out to be 1. The types of probability distributions. The probability distributions can be categorized under two broad heads, that is discrete probability distribution and continuous probability distribution. First we will take the discrete probability distributions. In case of discrete probability distributions, the variable under consideration is allowed to take only a limited number of screen values along with the corresponding probabilities. The two most important discrete probability distributions are the binomial probability distribution and the Poisson probability distribution. The second is continuous probability distribution. The continuous probability distribution describes an unbroken range of possible occurrences. For instance, the probability of having a baby with a weight of between 1 kilogram to 4 kilogram can be anything, or say will have infinite values. Thus, the random variable of the newborn baby is continuous with an infinite number of possible weights between 1 kg to 4 kgs. In case of continuous probability distribution, the variables under consideration are allowed to take on any value within the given range. The important continuous probability distributions are the exponential probability distribution and the normal probability distribution. The just mentioned different types of probability distributions are discussed later in this module. Now we come on to the technique of assigning probabilities. The researcher has to assign the probability values to the random variable. Since the assigning of the probability values is quite a tedious job, the researcher should have certain guidelines while assigning the probabilities. Like, the probability value will always lie between 0 and 1. That is, it cannot exceed 1 and cannot be less than 0. Secondly, the sum total of all the probabilities that are assigned to each of the value of the random variable must be equal to 1. Now we will start on the distributions one by one. First of all, the binomial distribution. The binomial probability distribution is one of the most extensively used probability distribution that is concerned with the discrete random variable. Binomial distribution describes the discrete data resulting from what is often called as Bernoulli process. For instance, the tossing of a fair coin a fixed number of times is an example of Bernoulli process, and the outcome of such tossing process, that is heads and tails, are termed as the binomial distribution. Whenever there is some random event that can result in only two possible outcomes are denoted as either a success or a failure, and every such event is termed as Bernoulli trial. For example, flipping of a fair coin is the most cited example of a Bernoulli trial. In case of flip of a coin, the outcome will always be either heads or tails. There is another term that is called binomial random variable. It is actually the total number of successes or failures observed in a series of n independent trials, and the list so prepared from the count of success or failures is termed as binomial distribution. For example, the number of times the heads comes up in toss of a coin twice is binomial random variable with the following binomial distribution as shown here in the table. Now, the outcomes in form of heads and the probability. The probability of having 0 heads is 0.25 and the probability of having 1 heads will be 0.5. Similarly, probability of having 2 heads will be again 0.25, and we calculate the probability for the tails. Probability of having 0 tails will be 0.25 and probability of having 1 tail will be 0.5. The probability again of having 2 tails will be 0.25. The expected value of a binomial random variable is its number of successes in the long run. The formula for the expectation of a binomial distribution is mu is equal to n into p. For example, the expected value for x being 2 tails will be n being 2 and the probability will be 0.5, which comes out to be 1. This is how we will calculate the value. Now we take the Bernoulli process. The binomial distribution is considered suitable in case of Bernoulli process. The Bernoulli process has the following characteristics. First, dichotomy. This means that each trial has only 2 mutually exclusive possible outcomes. For instance, success or failure, yes or no, in or out, and the like. Second is the stability. This means that the probability of the result of any trial is known and will remain fixed over a period of time. Third, independence. Independence means that all the trials are statistically independent. Here, it means that the outcome of any of the trial is independent of the outcome of any other trials. Now, we take on some of the parameters of binomial distribution. The binomial distribution depends upon the two parameters. These two parameters are the probability and the total number of trials. Hence, in the context of probability and the total number of trials, the usual generalization can be made as follows. When the probability is small, that is less than 0.5, the binomial distribution is skewed towards the right. On the other hand, when the probability of the sample is large, that is more than 0.5, the binomial distribution is skewed towards the left. However, if the probability remains at 0.5, the binomial distribution is equally distributed and symmetrical in shape. Now, the calculation of binomial probabilities. To calculate binomial probabilities, it is important to have an understanding of the concept of choose function by the researcher. This function quantifies the number of different ways to choose I number of objects out of n. The binomial probabilities or the total number of ways can be calculated with the help of following formula. Here in this formula, you can see the value of NCI stands for the number of different ways to choose I items out of n without repetition, and the factorial function. This formula can be better understood with the help of an example. Like, how many ways are there to choose 2 items out of 3? It can be computed as follows. Now you can see on your screen how the values are put in and how the result is obtained. It implies that there are 3 ways to choose 2 items out of 3. Now, if the 3 items are labeled as x, y and z, you may choose the combination like xy or xz or yz. The binomial probabilities can be computed with the help of formula as shown on your screen. In this formula, I stands for the total observed number of successes, N stands for the total number of trials, P stands for the probability of success for each trial, and Q stands for 1 minus P. The above formula can be better understood with the help of an example. Suppose we have to check the success of a drug with given information that probability of success in curing an ailment is 75%, that is P becomes 0.75. This drug is now administered to 4 patients. Here N becomes 4. Thus, it can be computed as, after this computation as you see on your screen, the value comes out to be 0.2109. The next distribution is the Poisson distribution. It is another type of discrete probability distribution. The Poisson distribution was developed by a Frenchman named Simon Denis Poisson, after whose name the distribution is now known. The Poisson distribution is frequently used in the context of operations research, and because of this, it has attained a great importance for the people of management. It plays a key role in the queuing theory, inventory control problems, and other risk models. The Poisson distribution is based on the experiences that are based on the empirical results of the past experiments, unlike the binomial distribution. Thus, the Poisson distribution cannot be deducted on purely the theoretical grounds. The Poisson distribution is most suited when the probability of happening of an event is small but n is very large. The concerned random variable in the Poisson distribution is the number of occurrences of a given event during a given interval. This interval may be of the time, the distance, the area, etc. Now, some of the parameters and important measures of Poisson distribution. The Poisson distribution depends on only one parameter, that is, the average number of the occurrences in every select specified interval. The probability of having exactly x occurrences can be found out with the help of Poisson probability function. For instance, the total number of footfall at a service counter in a specified time frame, say an hour, will have a Poisson distribution with lambda is equal to 4. Then the number of footfall at the service counter in a given period of 6 hours will have a Poisson distribution equal to 24, that is 6 multiply 4. Now, when to use Poisson distribution? The use of Poisson distribution is suited best in case when we do not know the value of n or the value of n cannot be determined with an accuracy. For example, in a game of football, total number of goals scored can be counted. However, total number of goals that could not be scored cannot be counted. Hence, the total sales, the total number of births in a specified time frame, total number of pages in a book will form the examples of Poisson probability distribution. Fitting a Poisson distribution. The Poisson distribution can be fitted with the help of the collected data as explained here. Now, first of all, determine the value of lambda, that is the mean of distribution. Second, estimate the probabilities of all the possible values in the given random variable using the Poisson possibility function. Thirdly, then work out the expected frequency as follows, like NP within brackets xi is equal to x. The next distribution is the exponential probability distribution. It is that distribution of time, say t, between events, and this becomes a part of continuous probability distribution. In the exponential distribution, generally the question arises as to what is the probability it will take x number of trials before the first occurrence. This distribution is useful when the researcher has to describe a large class of phenomena, specifically in the area of reliability theory and in the queuing models. Probability day function of exponential distribution is described as per the formula on your screen, where the lambda is the average length of interval between two occurrences and E stands for 2.7183 being the basis of natural algorithm. The next part is the normal distributions. The probability distribution considered above was of variables with only two possible outcomes, that is success or failure, people with or with an attribute, or positive or negatives. The random number of successes of n made up a binomial distribution. The variable was just an enumeration of the number of successes and was thus termed discrete. Normal distribution is another kind of variable whose individuals are measured for a characteristics such as height, weight, age, etc. The variable flows continuously without any breaks and thus termed as continuous, without any limit to the number of individuals with different measurements. Such measurements are distributed in a number of ways. However, the most prominent is explained here as it has got a great utility and wide use in applied research. Whereas discrete probability distributions or binomial distributions are displayed with the help of histograms, continuous probability distributions or normal distributions are displayed with the help of curves. Here you can see one of the curves. The probability curves demonstrate the following important properties. The total area under the curve sums to 1. The area under the curve, also denoted as AUC, between any 2 points is the probability of values in that range, that is the shaded area. The probability of any exact value is equal to 0. These above mentioned properties allow determine the approximate probability of various potentialities using a variety of probability tables. Out of all the distributions, it is the normal distribution that is most frequently used. This is due to the reason that this distribution fits the best in most of the problem. Normal distribution is also known as Gaussian distribution because of the contribution of 18th century mathematician and astronomer Carl Gauss. The normal distribution can be practically obtained as a limiting form of a number of discrete distributions. Characteristics of normal distribution. The characteristics of normal distribution are of those that of a normal curve and are presented below. First, it is a symmetric distribution. Second, the mean, that is mu, defines where the peak of the curve occurs. In other words, the ordinate at the mean is the highest ordinate. The height of the ordinate at a distance of 1 standard deviation from mean is 60.653% of the height of the mean ordinate, and similarly, the height of other ordinates at various standard deviations from the mean happens to be up its relationship with the height of the mean ordinate. The curve of normal distribution is asymptotic to the baseline, which means that it continues to approach but never touches the horizontal axis. Fourth, it is the variance that defines the spread of the curve. Fifth, the area between the mean ordinate and an ordinate at a distance of 1 standard deviation from the mean is always 34.134% of the total area of the curve. Sixth, the normal distribution has only one mode since the curve has a single peak. In other words, it is always a unimodal distribution. There are two parameters that decides the normal distribution, that is mu and standard deviation. The mean determines the distribution's central location. The figure over here shows two normal distributions with different means. The standard deviation of a normal distribution explains its spreads. The next figure exhibits two normal distributions with different spreads as shown over here. Now, for all normal distributions, 68% of the data lies within the plus minus 1 standard deviation of mu. 95% of data lies within plus minus 2 standard deviation of mu. Nearly all of the data lies with plus minus 3 standard deviation of mu. Friends, let us now summarize the module. The present module explains the basics of probability and its distribution. Probability is in simple terms is a measure of chance. There are two schools of thoughts that describes probability, namely on logical experience and quantifiable level of belief. The probability of an event may vary from 0% to 100%. If there is a possibility of occurrence of an event, say 20%, then probability of non-occurrence of that event must be 80%. There are two broadly categorized types of probability distribution, that is discrete and the continuous, which are further divided under two heads. Shape of a perfectly normal distribution is always bell-shaped and may sometimes get skewed to right or left side. Normal distribution is the distribution that is widely used in different types of research and other activities. Thank you.